So what are we going to learn today? We will be learning how packets are delivered in a packet switching networks. How packets are transferred from source to the destination. Okay. So especially we will see how these packets travel in the network layer. Okay, with respect to network layer, let's see. We have learned that packet switching, so there are different nodes. Think of that as a router. Okay, different routers we learned. So uh, this internet works on a packet switching. There are two types of networks: circuit switching and packet switching. Circuit switching, data is not divided as chunks. In packet switching, data divided as a small packets, right? Whole data, if you have a single file that is sent as a small chunks, each chunk is called packet, and this is called protocol data unit. We have different names in different levels. In a IP layer, in network layer, we call that as a packets or datagrams, right? In a transport layer, we call them segments. In a data link layer, we call them frames, right? So it can actually, if it needs to be actually, this is destination, it can travel this way, or it can travel this way, or it can travel this way. Do you get it? So think of these as routers. So how this packet, so there are different total, these many different uh, ways are there to reach the destination. And see how this is so much complex than we discuss as it seems. And we will see today uh, how this delivery of packets is handled in a network layer. So what is a delivery? Delivery is packet delivery is nothing but how these packets are handled in a network layer. Okay, the forwarding refers to the way these packets are moved to the next station. Okay, we can call them, there are multiple stations, call each station can be a router. Okay, so until it moves from one node to another node, finally it reaches the destination. Okay, so what happened, packet will be forwarded from one station to another station, one node to the another node, and finally reaches the destination. Okay, so here there are two types of deliveries: indirect delivery and direct delivery. Okay, so there are two types, which is indirect, okay, and direct. Okay, so indirect delivery and direct delivery. So let's say that what happens, we have seen the other day, uh, we we did run the trace route or trace path command to google.com. So we have seen that different hops that packet is going. Okay, think of that, each one as a router. Okay, yeah, each hop is a router. Okay, so let's say packet needs to reach some destination 44.54.72.5. Okay, and the source is a source computer, is that computer is connected here. Okay, so this is network, this is one network, right? Yeah, so and we have a source computer here. Okay, so this is some let's say this is home computer is 192.168.4.8. Okay, so think of this as ISP. Do you get it? Yeah, the route connected to ISP. So yeah, so this can be anything for our understanding. I'm just making it. Let's make these assumptions. So if this packet needs to travel, of course there can be, we can make this thing and even complex. There can be different routers connected to like this. Do you understand? Okay. Do you get it? Yeah. So to make it simple, just make it linear. Okay. So there are these different routers connected. Okay. So which means that different networks. Okay. So think of this way. Here, these routers are connected, which means this is one network. Do you understand? This is this is a common network. This is a common network. This is a common network. Okay. This is another network. Okay. Yeah. So this is a physical network here. So how packet travels? Packet actually take a packet. It moves from to this router. Router determines. See, uh, for to make it meaningful, we have another two networks connected here. Okay, but router determines it. It should not travel to this way, or this is not a correct way. This is the right path. So it will send to the this destination. Okay, yeah, this will this destination. Okay, so that way packet travels from one so one routers to, yeah, different hubs. You can, uh to make it even meaningful, we can actually have, let's say that from here we can have a uh, this switch, and we have different computers connected to here. Do you get it? Okay. So this, like this there are different networks. This is whole thing is one network. So here, what is direct delivery and what is indirect delivery? So if packet is traveling, if okay, so here, if source, okay, and destination, okay, are in the same physical network, it is a direct delivery. Okay, okay. So direct delivery is always happens at the final destination. Okay, so this delivery, if source and destination are connected to different physical networks, what happens? There will be multiple indirect deliveries and finally a direct delivery. Okay, so see here, I have another computer connected here. Okay, so if packet needs to computer A, computer B. I want to communicate with this B. So what kind of delivery is here? Packet delivery. So what is a forwarding? Forwarding is the way the packets are moved to the are sent to the delivered to the next destination. Okay. Delivery refers to the how these packets are handled by network layer. Okay. This net how these packets are handled. So here, see how when you send a message to B, when it is a direct delivery because these two are connected to same physical network. Okay, so for example, you have your system connected to Wi-Fi and your phone connected to the Wi-Fi. If you send, and if you want to send, if uh, and your Wi-Fi, your sorry, your laptop and phone both needs to be communicated. The what kind of delivery is there here, which is a direct delivery because they are connected to the same physical network. Okay, so direct delivery is very simple, straightforward. The how come source knows it is a direct delivery or indirect delivery? See, this is a source. If a source, uh, if this IP, yeah, yeah, both network, if the destination network of the destination IP and the network the source is connected to are same, then it is a direct delivery. Yeah, how do you know the so the how do you, no no what is it? I didn't get your question. Yes, yes, router. See how these devices are direct. The devices won't be connected to router directly. Here we'll have a switch here. Okay, so switch is connected to, okay, router. So switch will provide a multiple ports and our devices are connected. Let's say that it is 192.168.4.7. It is 192.168.8.9. Sorry, not 8, 4. It is the same network. 4.10 or, and what is subnet mask? It is 255.255.255.0. Okay, which means the last octet only the host ID. Okay, or the suffix in classless addressing. So so here, so when it wants to this kind of packet delivery, this it doesn't change for the both the classful addressing and classless addressing, but the routing table changes. The how router maintains uh, routing table for classful addressing and classless addressing. We will discuss that. But let's see that here it is sending to this destination from 4.7 to 4.10. What is the network address here of the destination? How do you get the network address of the destination? Perform AND operation between 4.10 and the subnet mask or net mask. Right. So what do you get? What is network address? 4.0, right? Okay. So if the source checks the destination network address and the network to which this source is connected, if both are same, it will be simply the direct delivery. Okay, it doesn't go beyond the router. Okay, it doesn't cross the router because the packet is direct delivery. Okay, do you understand this one? Yeah. So if packet is packet is when it will be the indirect delivery, the one, yeah. So we took here instead of 192, let me take a 172. Okay. So okay. So instead of this IPE, this is totally just want a totally different network. Okay, or 10.4.0.5. Okay, some different network address. Okay. So need to reach this. This is a public IP. Just think of this one. Okay, these are we use the private IPs here. This is the WAN IP. Okay, the WAN IP of WAN end, right? Okay, so let's say that we want to send the packet needs to reach this one. Okay, for the sake of simplicity, just consider this one. Okay, 44.54.72.5. Okay, so here, what is network address? Network address is, let's say, based on the, it will be the based on yeah, so prefix. Okay, but yeah, slash 24 or any, so that based on prefix. Okay, the forget about which is whether it is classful address, classless address. See, if it wants to reach to the destination, we know that these two are different networks. So when it is a different network, so packet is indirect. With indirect delivery, packet will reach to the next destination, intermediate destination, intermediate station. Okay, yeah. So and from there it will reach to the next station. So what happens? IP address will be the same. This is the destination IP. So it will check that. We will see in a moment. It will make sense when we see the how routers find the next station. Okay, so routers find the next station based on there are different kinds of routings: static routing, dynamic routing, default routing. Okay, so based on routing, we this finds the next station, and based on the routing configuration, it will find the next station. Okay, for this IP, and it will like this. This is an indirect delivery. This is the indirect delivery, and this is indirect delivery. And finally, once it reaches the final station, a final router, okay, it will check that its network and the destination network network of the destination IP both are same, so that packet is delivered through direct delivery. Okay, so one thing here, in each case there will be many indirect deliveries. Okay, yeah, deliveries, and there will be at least, okay, and one and only one direct delivery. Do you get it? So when, yeah, when source and destination both, this A is communicating B and there is no indirect delivery involved. Okay, there can be zero or many. Okay, zero or many indirect deliveries. Here A is communicating B in the same network. There is no indirect delivery. It is a direct delivery. Zero indirect deliveries involved. But when there is a some far away, some computer is wants to send a message to a destination which is connected to different network. There are many different networks in the middle, and there will be many indirect deliveries. How many indirect deliveries involved depends on number of hops. Okay, and once it reaches the final destination, final router, there will be a direct delivery. Okay. Okay, so uh, to reach router, the packet, as packet travels, packet goes from router to router until it reaches the last router connected to that physical network. Do you understand? Here, how many routers? Here, many routers we have connected. The packet is going from router to router until it reaches the router that is directly connected to the network to which our destination is connected. Okay. The once it reaches the physical final router that is uh, connected to the network to which our destination is connected, direct delivery happens. Okay. So now let's see that how these routers. So there are actually, what is this? We learned this is a forwarding. Okay, the how packet is delivered to the next station. Okay, so this forwarding, actually there are different actually techniques, and one of the and today's we use, and one of the prominent one is based forwarding based on destination address. Okay, so here forwarding based on destination address. So every time as packet moves, these routers check the destination address and determine what is the next station. Yeah, next station. The next station can be another intermediate router or a final destination. If another intermediate router, which is indirect delivery, final destination, which is a direct delivery between the router that is connected to the destination network to the destination. Okay, so here how forwarding happens based on the destination address, there are different techniques. Okay, So for that reason, routers maintain temporarily a database. Okay, routers maintains routers maintains what? A small database of destinations it is connected. Okay, and how this database, what kind of database, depends on what kind of method the routers use. There are three different methods here. One is a next hop method. Okay, and another one is a network specific method, it is called. Okay, yeah, next hop method, network specific method, and another one is a host specific method. Okay, host specific, and another one is a default method, and we can use these multiples of methods combined. Okay, and I hope these things will make sense in a moment once we discuss. Okay, so see, uh let's say that router wants to, it is if this router is router A, let's name these things A, B, C. D is a destination router, final router. So if A wants to send message to B, and A should be aware of that B router is there. Do you get it? Yeah, and also A should be also aware of C router is there, and D is there. Okay. So what happens if our home router, we have our home router, right, from ISP connected. So basically, this is the next stop method. Okay. So yeah, next stop method in this technique, router maintains the routing table. This database is called what it is called? It is called routing table. What router maintains internally in our memory. Okay. So even we have that, we can see the routing table in our system. Okay. Route. Uh, just let me check. Why is it not working? System. Hello, hello. So which one are you using? Mac, right? Yeah, here is the routing table. Okay. See, our system itself actually maintaining. Hello. If it is a Windows, we can type route space print to get the routing table. So our system itself, you see, maintaining the routing table about the way to send, what is the next destination, all of those things. Okay. So here, let me, so that way, see our system itself maintaining like that. Here, routers also need that information about next shops. Yeah. So using next stop method, this information where these routers share that information, store that information, that is called routing routing table. Okay, routing table. Okay, so they actually store that information in a RAM, random access memory. Okay, so that whenever packet comes, what router performs, we have learned about net mask, and this is where router uses the net mask. So router calculates the uses the net mask and find out the network address, and checks the compares router compares whether uh, it has that network connected or not. Okay, and if connected, it will get that particular interface to which that network is connected, and it will send through that over that port to that to which that to which port the destination network or next network is connected. So anyway, here, so in a next hop method, router holds the address of the next hop. Okay, so usually without next stop, this is the next. In general, without the next stop, what happens? Router needs to know about a router needs to know about B, C, D, all those different routers. So let's write this thing. Let's say that you take a router A. Okay, if you write this router, let's say that destination. Okay, destination and route. Okay, so what is route? The route to which this packet should take to reach the destination. Okay, if the destination is, let's say if the destination is here 192.168.4.10. Okay, so this is which routing table of A. Okay, router A, this one. Okay, destination is this one, B. Okay, so if it is destination 4.10, this router should contain should store the complete route, which is let's say router B, router C, and router D. Do you get it? Do you get it? But that is not a, yeah, this is not a practical thing. If it is a, this is a, let's say that in a forward thinking. So if router, this is not a next hop method we are discussing. This is not a next hop method. Next hop method, we store only next hop. In general, router needs to know about the complete route, and router store that router is required is to store the all IP addresses. Instead of RB, we can store the IP address of this one. Okay. So like that, each router, let's say that router B may need to have the destination, okay, the same 194.10, and it will have a C comma D. Okay, router C comma router D. So like that, each router needs to, yeah, yes, router. So here, like that, for this destination, this router need to know about all other routers. When it comes to router B, for the same destination, it need to know about all other routers to store the complete route. But this is not practical. Think of when we have a 30 hops or 32 hops, and even lot of hops. It takes lot of memory, lot of space, and it is complex. It is hard to maintain. Okay. So, instead of storing a complete information about the complete route, in a next stop method, router store only the next stop. Okay, only the next stop, and and everywhere we and in every place, in everywhere we when we configure, we use the next stop method only. Okay. Yes. See, let's write down the uh, how routing table looks like. Use it in a next stop. Just a moment. So here for router A, what happened? Router A stored complete route about B, C, D, and A. So, but when it comes to the next stop method, yeah, see there are different types of routings: static routing, dynamic routing, and in a static routing we configure manually. We go there, we log into the router, and we say, tell about all networks connected. Okay, so networks connected. Okay, and in a dynamic routing, router learns about the different networks connected automatically, dynamically. Okay, so so how does the router know about next stop method? Either router sends randomly some packets and find out the using dynamic routing protocols, it will learn about different networks connected, the which means the next stops. Okay, or else we administrators configure manually for a greater control, which is called when we manually tell the router about the different networks connected, about the next stop. When we write the those routing, um, configure that routing manually, which is called static routing. Okay, so here if we take this router A, so what so far what we have discussed the routing tables based on the route. Okay, the where each in this based on the route method, each router stores the complete route uh, about for the destination. Okay, that is not ideal, that is complicated, but in a next stop method, and this is where everywhere now we use. Okay, in your computer or in your in our routers, okay, home routers, everywhere we see the next stop only. So in router A, for the destination, okay, for the destination 192.168.4.10. Okay, what is the this is a destination. What is a route? B. Yes, B, which will be router B. Okay, only B. That is next stop. For router B, For router B, yeah, destination is same 192.168.4.10 and router C. Okay, and the same thing is for router D. Okay, which is router C. For destination is 192.168.4.10 and the router D. What is this? This is destination. Okay, and this is next hop. Okay, so tell me one thing. There is one catch if you can find here. What we are storing? We are storing destination by IP. Imagine we have 100 computers in each network. So do we need to list all 100 computers as a destination? Yeah, if you use next hop method, yes. Do you understand? Here, yeah. So here we have 192 dot. This network is, imagine this network. We have 192.168. Okay. 256 computers, 4.0, which is network, which means that the how many computers? 256 from 0 to 256. Of course, first and last IP we can't use 0 to 255. Sorry, first address is 0, 4.0, last address is 4.255. And first and last address we can't use since first is a network address, last is a direct broadcast address. So we have this wide range of computers, but imagine this destination for router B, for all addresses from 192.168 4.0 to 4.12 4.254, it needs to list all those addresses. Please don't get lost here. For all these addresses like 192.4.10, for 192.168.4. 11, router B needs to include router C as a next hop. Okay, and also likewise, see, yes, of course, for a specific IP address means, let's say if those addresses are being used. Okay, so the addresses are connected. In such a case, if router B is here, and there is also router X is here connected, RX. Okay, for these addresses, packet should go to router C instead of router X. So in such a case, for all those destinations, we should have RC included, right? Yeah. So that is same way. All these 254 addresses, right? 254 addresses, because removing first and last addresses. Yeah, 254. They also need to be included in router A. So for all those addresses, what is next hop here? Router B for router A. Okay. For all those addresses for router B, next hop is router C. So here, if you can think, can't we summarize all those addresses as a single address? Can't we represent all those different addresses as a single address? We can. That is the network address. Can't we represent all those addresses using network address? Yeah, go to, see here, 192.168.4.0. Okay, let's take a 4.1, which is the first IP, 24. How many addresses we have? 256. for 254 addresses, instead of listing all addresses from 192.168 4.1 to 4.254, can't we list just the network address, which is the first address? We can do, right? Because packet should reach the network first, then it will go to the host destination. Instead of listing all those specific addresses as in a destination column, why can't we use the network address in a destination column? Because this network represents all these addresses, right? See, if I give you, let me ask you a simple question. If I give you this network address, can't you tell me how many addresses are there in that network? Yes, you can. If I give you a network address, you know that this is and a prefix length. Okay. You know that host portion, which is a 32 minus 24, which is 8. Right? And you know that number of addresses in that network. And you know the first address and last address. And you can summarize all those addresses as a single address, which is a network address. So that is where this network specific method comes in. Okay, instead of listing all these different addresses, destinations, we can actually, let's say that here this is 256 addresses only. Let me take another 45.24.25.5. So prefix take 16. How many addresses we have? 65k. Prefix is just 16. So classless address. This is a classless addressing. Okay. So here prefix is flexible, right? So we took the block prefix 16. In such a case, how many addresses in that block? 65k addresses. So if you use a host next hop specific, of course, the network specific also next hop specific, next hop method. So here we include the next hop, but instead of a whole destination, individual host address, we include the network address in a destination. So in a destination, instead of including the all 65k addresses, instead of maintaining all 65k addresses in a routing table, we can use this network address in a routing table to represent 65k addresses. So that is the next network specific method. Okay, so here also destination is a next hop. Okay, this is combination of both next hop and network specific. So in that method, let me erase this thing. Just give me a moment. See, next hop method, instead of using complete route, we use what is next hop method? Next hop method, instead of RB, RC, RD, which is complete route, storing a route, okay, which is based on route method. Okay, instead of storing complete route, the routing table, router stored just about the next stop. What is next stop means? Just about the next station. Okay, so let's say that I'll give you a simple example. You are sending me a letter from Delhi, okay, to Hyderabad. So Delhi post office, no need to know about all post offices in the middle. Okay, but it may, of course, if it want, it can know all those post offices. That is overkill, right? Instead of that, it is also possible Delhi post office just need to know about the next destination where it needs to send the letter. that is the next hop specific method. Do you get it? So likewise, each post office in the middle need to know about the just next post office to reach the destination. Okay, that is next stop method. So instead of storing complete route, we store the just next stop. And here in what I discussed is a host specific, next stop and host specific. Okay, the where next stop and host specific, which is in which each host address of each host is listed in a destination with a next stop for each host. Okay, do you get it? But instead of maintaining the having all hosts in a routing table, we can summarize use a network. Okay, and desktop next stop is used in combination for a both host and network specific. Do you get it? No, yeah, host specific is just using IP address. This is what the host specific we used. So far, what we learned, host specific, because we are in a destination instead of network address, we are including all IP addresses. Address of the host, address of the destination host. In a destination, in a routing table, if we use the address of the host, which is the address of the computer, okay, destination, we that is a host specific. Network specific is instead of including all addresses in the network, if we summarize that everything as a replace that whole thing as a with the network address, that is a network specific method. Okay, so what is another is a default method. Okay, what is default method? Default method is, let's say that I got some packet delivered here, this router. Okay, but it found that all destination, it scanned all of its routing table entries, but it didn't find any destination. Okay, so in such a case, default route is the last resort. Okay, where packet is sent to the default route. Okay, so for example, let me explain you default method. So I'll explain you this with one example. Let's say that in your home, your phone is connected, your phone is 4.7. Okay, and the destination is 4.10. It will reach to the through direct delivery, it will reach to the computer 4.10. Okay, but let's imagine you want to communicate with 45.84.9.10. So can you, in your routing table, can you list all 4 billion addresses? No. So you don't know about complete routes. Do you understand? In your home router, so is your home router listing all 4 billion addresses? No. Do you get it? So instead of 4 billion addressing everything else, we use a single route called default route, which is the last entry in the routing table, where everything else goes to the default route. Here, what is the default route for your home router, which is ISP? Okay, so when in your routing table contains, if there are different networks, routing table lists all those destinations by network, and it scans all those entries. If nothing is found, there would be a default route, which is also gateway. Okay, is also called gateway, or also called gateway of last resort. Okay, so anything else, any destination that is not mentioned in the routing table, and or a destination is not found in routing table, that will be sent over the default route. Okay, so if there is no default route, what happens? Packet will be lost. Okay, packets will be lost. Okay, so for you, let me show you Okay, so let's start here. Can you see default route? Default. What is this? The what next stop is mentioned as what? Gateway, which is my router, uh, router that is connected to WAN. Do you get it? So see, there are this different routes for this is a network specific method. Do you see here? Do you see this one? 192.168.1.32. So which is a, yeah, and there is a, this is these are actually the here next stops are there, and the what gateway is next stop, okay, and interface to which it is connected to, okay, and so here there are actually different the lot of entries are there, and same way router also maintains, and it since it can't list all IP addresses, all networks on the internet, and anything it doesn't know will go to the will go over the default route to the default gateway, okay, which is called the router, which takes the typically the what will be the default gateway, any router that is connected to internet typically. Do you get it? Yeah. So okay, and that is a next stop method, network specific method, host specific method, and default method, okay. So here let's learn about let me create a new one. Okay, so here let's learn about how this routing happens. Okay, so we no longer use uh we no longer use classful addressing, right? So this is not used. Routers no longer maintain the store routes according to the classful addressing architecture. But when classful addressing was active, routers used to maintain three routing tables for three classes. Okay, class A, class B, class C. So what routers use? Routers use, see, we can use both network specific and host specific combined. Routers use network address, which is a destination. Do you get it? And next stop, next hop, and interface. Okay. Yeah, interface. So see, if we take a router, there are different interfaces, okay, so we call that as there are different namings, okay, M0, M1, M2, M3, okay. So we have seen that interface also here. There is an interface for a, what is the interface name? Yeah, EN1, which is interface name for the my wireless connection here, okay, network card. What is LO, which is a interface name for the local host, okay. So likewise, see, each interface is also identified by the unique name. If you have multiple cards connected to your system, then you will see multiple interfaces, okay. Here EN0 that is not listed here, that is Ethernet, okay. So if I can see, do you see interfaces here, different interfaces? Yeah, yes. Okay, EN1 is the wireless one. EN0, EN4, that's different interfaces are there. So routers maintain is to maintain the interface, these so in a classful addressing, routers used to maintain these different, each three tables, different tables for each class, class A, class B, and class C, and each table contains a network address, next hop, and interface. And you know already, when for suppose when IP address receives, okay, so let's say that destination IP is 192.168.5.10. The what is the class of this IP address? Routers in a classful addressing, routers know already class of the address. So in a classful addressing, what values are predetermined? One, if IP address given, routers know class and net mask, right? Why? Because each class has a default mask associated with. For class A, which is what is a for class A, what it is 8, right? Mask is for class A 8, class B 16, class C 24. So they don't. So they if IP address is given, they routers know already in classful addressing. Based on IP, router can find the class, can find the net mask, can find the network also. Okay. Okay. So in a forwarding, in a classful addressing, routers know with the IP address given, routers know class of the address, net mask, network. How does they know the class of the address? Based on the first octet, first 4 bits, right? If first 4 bits are starting with the, we have this table, yes. So here, first bit starts with 0, which is class A, 10 class B, 110 class C. So 192, from 192 to the 223, what is it is? Any IP address that falls under this range is a class C. And if class C, we know router finds the class C based on the first IP, first octet. What happens? Router extract the first 4 bits. Okay. If first 4 bits are starting with 110, it can see that the destination IP address is class C. Okay. So what are we discussing? We are discussing the forwarding process in a classful addressing. Okay. So we have a router. This router, let's imagine this router is given. Okay. And packet is coming. Okay. Packet is coming from M1, source M1. Okay. Interface M1. It is coming on interface M1. The way to send this packet. Okay. There is a different network connected here, different network connected here, connected here. The way to send. Okay. So different network means here different router is here. Okay. Way to send this packet. So that is where the router makes these decisions. So it can see that coming address is one, destination address is. Well, how can router find the destination address? It can capture the destination packet that is coming, and we know that, right? OSI layer, right? In a OSI layer, we have seen encapsulation, decapsulation. And the packet is encapsulated, and within a frame, we have a header, tail for the frame, and what is the next layer? Data link layer, right? physical layer, data link layer, and then network layer. Network layer contains header and then body, right? And this body contains header, again header for the transport layer if it is a TCP. So it extracts this packet, and from header it can find the destination address, right? It can find the destination IP, and assume that destination IP it received is a 192.168.5.10, and based on this one, which class it is? Class C. And what is the net mask? Which is 24. Okay, it is class C 24. And what is the based on from net mask you can get the default net mask, and with the default net mask you know what is the network address. What is network address? 192.168.5.0, right? So what is the destination network here? Yes, network hop interface. So you will have a different entries for different networks. Okay, here 192.168.5. Let me write it down so it will be clear. 192.5.0, which is one network. 192.168.6.0, another network, right? 192.168.10.0, which is another network, like that. So what router does, it found that the destination, the class of the destination IP is class C, so that it will check which table? Class C routing table. Okay, and class C routing table, and for class C routing table you will have entries. Do you have a network address in a class C? 5.0, right? Yeah, and for that it will find the next stop. Let's say that for the next stop is for a 5.0, this is M0. Okay, the address of the next stop here 192.168.5.1. okay, this is M1. Okay, this router of this IP, or let's say this is called R0, and this is R, call it as a RA. Okay, so what is next stop? IP address of that address of IP address of that interface. What is this here? This address. Okay, so which is 192.168.5.1, and to which interface it is connected to this router R0, M0. Okay, so what router does? M0 router, sorry, R0 router takes, found that there is a net entry for that network. It found that next stop is 190.162, and that next stop is connected over the M0 network, M0 interface. So it will, that packet will this R0 router will send that packet to this IP 190.168.5.1. okay, connected on an interface M0. Okay, so this packet is coming here over the interface M1. It found that there's a router connected over the interface M0, and the address of that router is 192.168.5.1, so that it will send that to this IP over this interface. This is routing of CC. We have to give both here in a routing table. Okay, this both interface and the next stop. but next hop will be nothing, empty, for a direct delivery. See here, another packet is coming from M1, okay, which is the network is 192.168.6.0, which is this network connected here, okay, and the packet is coming from 192.168.6.5 and destination is 6.10. And for this router like this, each router maintains the routing table, okay. And what we are discussing forwarding for a classful addressing, and this is, we no longer use this classful addressing, but we are learning, because classless addressing is nothing different, but there will be extra column we will discuss. So for this R0, for the destination for this network, what is the next stop? For 6.0, what is next stop? Nothing, because that is direct delivery, and which interface? M1, okay. This is how the forwarding happens with a classful addressing architecture. And this is how each router maintains 3 different routing tables for each routing table for each class. Now let's discuss forwarding for a classless addressing. We will discuss classless forwarding for classless addressing in the coming session, okay.